Hello everyone. In this video, we will solve some problems based on op-amp. Let us take the first problem. An op-amp has an open loop voltage gain of 10 to the power 4 and a common mode voltage gain of 0.1. Express the CMRR in dB. So now open loop voltage gain AOL is 10 to the power 4 and common mode voltage gain ACM is equal to 0.1. So now we know that common mode rejection ratio CMRR is defined as the ratio of the open loop voltage gain to the common mode voltage gain, that is AOL divided by ACM. So AOL is 10 to the power 4 and ACM is 0.1. 10 to the power 4 by 0.1 is equal to 10 to the power 5. So CMRR is 10 to the power 5. So now here we need to express CMRR in dB. CMRR in dB is equal to 20 log of AOL divided by ACM. So 20 log of 10 to the power 5 is equal to 100. Now let us take the next one. A certain op-amp has an open loop voltage gain of 1 lakh and a common mode voltage gain of 0.1. Express the CMRR in dB. So again, this problem is similar to the previous one. Open loop voltage gain AOL is 1 lakh and common mode voltage gain ACM is 0.1. Therefore, CMRR is equal to AOL by ACM is equal to 10 lakh by 0.1 is equal to 10 to the power 6. So now in CMRR in dB is equal to 20 log of AOL by ACM is equal to 20 log of 10 to the power 6 is equal to 120. So now we will solve some problems based on inverting and non-inverting amplifier circuit. Okay, so an inverting amplifier circuit has input series resistor of 20 kilo ohm, feedback resistor of 100 kilo ohm and a load resistor of 50 kilo ohm. Draw the circuit and calculate the input current, load current and the output voltage when the applied input voltage is equal to plus 1.5 volt. So here in this problem, input series resistor is R1. R1 is equal to 20 kilo ohm. Feedback resistor RF is equal to 100 kilo ohm and load resistor RL is equal to 50 kilo ohm. So in the inverting amplifier, input is given to the inverting terminal of the op-amp and non-inverting terminal is grounded. So this is an inverting amplifier circuit, okay, and feedback resistor RF is equal to 100 kilo ohm and series resistor is 20 kilo ohm and then load resistor. So load resistor is connected between the output voltage and the ground. Okay, it is connected between output voltage and the ground. And this RL is equal to 50 kilo ohm and input voltage V in is equal to plus 1.5 volt. So now input current I1 is equal to V in by R1. V in is 1.5, R1 is equal to 20 kilo ohm. So 1.5 by 20 into 10 to the power 3 is equal to 0.075 into 10 to the power minus 3 amps. So next output voltage V0 is equal to, so in inverting amplifier circuit, output voltage is equal to minus RF by R1 into V in. So which is equal to minus 100 into 10 to the power 3 divided by 20 into 10 to the power 3 into V in 1.5 volt. So is equal to minus 7.5 volts. So the output voltage V0 is equal to minus 7.5 volt. So now the load current IL is equal to equation to calculate the load current is V0 by RL. So IL is equal to V0 by RL. So minus 7.5 divided by 50 into 10 to the power 3 is equal to minus 0.15 into 10 to the power minus 3 amps. So now let us take the next problem. A non-inverting amplifier has input resistance 10 kilo ohm and feedback resistance 60 kilo ohm with the load resistance 47 kilo ohm. Draw the circuit and calculate output voltage, voltage gain, and the load current when the input voltage is 1.5 volt. So here in the non-inverting amplifier circuit, input is given to the non-inverting terminal of the op-amp. Okay, so here series resistance R1 is equal to resistor R1 is equal to 10 kilo ohm, feedback resistor 60 kilo ohm, and the load resistor RL is equal to 47 kilo ohm, and the input voltage V in is 1.5 volt. So let us calculate the output voltage first. Okay, so equation to calculate the output voltage is V0 is equal to voltage gain into Vin. Okay, so now here voltage gain is not given in the problem. So first, because we need to calculate voltage gain also in this problem. So first calculate voltage gain. So we know that voltage gain AF is equal to 1 plus RF by R1, which is equal to 1 plus 60K divided by 10K. So therefore voltage gain AF is equal to 7. So now the output voltage V0 is equal to gain into input voltage. Okay, so it is equal to 7 into 1.5. So the output voltage V0 is equal to 10.5 volt. So now load current IL is equal to V0 by RL, 10.5 by 47 into 10 to the power 3 is equal to 0.2234 milliamps. So now let us take the next problem. Calculate the output voltage of a 3-input summing amplifier. So this problem is related to inverting summing amplifier. So we need to calculate the output voltage of 3-input summing amplifier. So here R1 is equal to 200 kilo ohm, R2 is equal to 250 kilo ohm, R3 is equal to 500 kilo ohm, and feedback resistor RF is equal to 1 mega ohm. V1 is equal to minus 2 volt, V2 is equal to plus 2 volt, and V3 is equal to plus 1 volt. So here we know that for inverting summing amplifier, output voltage V0 is equal to minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. So now substitute the values for RF, R1 and V1, V2, V3. Okay, so minus of 1 into 10 to the power 6 divided by 200 into 10 to the power 3 into V1. V1 is minus 2 plus 1 into 10 to the power 6 divided by 250 into 10 to the power 3 into 2 plus 1 into 10 to the power 6 divided by 500 into 10 to the power 3 into 1. So it is minus of minus 10 plus 8 plus 2. is equal to 0 volt. So in this summing amplifier circuit, output voltage is equal to 0 volt. Next problem. Design an adder circuit using op-amp to obtain the output voltage of V0 is equal to minus of 0.1 V1 plus 0.5 V2 plus 2 into V3, where V1, V2 and V3 are input voltages. Draw the circuit diagram. Okay, so now here to draw the circuit diagram of an adder circuit, we need to calculate the resistor values. Okay, so as we know, this circuit is adder circuit with three input voltages V1, V2 and V3. So we know that output voltage in the adder circuit V0 is equal to minus of Rf by R1 into V1 plus Rf by R2 into V2 plus Rf by R3 into V3. So now here the given equation in this problem is V0 is equal to minus of 0.1 V1 plus 0.5 V2 plus 2 into V3. So now compare these two equations. So we get Rf by R1 is equal to 0.1, then Rf by R2 is equal to 0.5, then Rf by R3 is equal to 2. So here feedback resistor value is not given in the problem. So assuming Rf is equal to 10 kilo ohm, feedback resistor Rf is equal to 10 kilo ohm. So now here in this equation, R1 is equal to Rf by 0.1 is equal to 10 kilo ohm by 0.1 is equal to 100 kilo ohm. Similarly, R2 is equal to Rf by 0.5 is equal to Rf is 10 kilo ohm by 0.5 is equal to 20 kilo ohm, and then R3 is equal to Rf by 2. So 10 kilo ohm by 2 is equal to 5 kilo ohm. So now here this is a summing amplifier circuit with the three input voltages V1 and V2, V3. So here V1 is supplied through the resistor R1 and V2 is applied through the resistor R2 and V3 voltage is V3 is applied through the resistor R3. It is applied to the inverting input terminals of the op-amp and non-inverting terminal is grounded, and the output feedback is provided between the output voltage. So it is provided from the output to the input terminal, the op-amp. Okay, so next consider this. Design an adder circuit using op-amp to give the output voltage V0 is equal to minus of 2 V1 plus 3 V2 plus 5 V3. So now again we know that V0 is equal to minus of Rf by R1 V1 plus Rf by R2 into V2 plus Rf by R3 into V3. So now comparing equation. So the given equation is V0 is equal to minus of 2 V1 plus 3 V2 plus 5 into V3. So now comparing equation 1 and 2, we get Rf by R1 is equal to 2, then Rf by R2 is equal to 3, then Rf by R3 is equal to 5. Again assuming, because RF value is not given in this problem, so assuming Rf is equal to 10 kilo ohm, R1 is equal to Rf by 2, 10 kilo ohm by 2 is equal to 5 kilo ohm. R2 is equal to Rf by 3, 10 kilo ohm by 3 is equal to 3.3 kilo ohm. Then R3 is equal to Rf by 5 is equal to 10 kilo ohm by 5 is equal to 2 kilo ohm. Okay. So this is an inverting summing amplifier circuit. Okay, so the last problem, find the output of the following op-amp circuit. So here, so there are three inputs. Okay, V1 is equal to minus 4 volt, V2 is equal to minus 2 volt, and V3 is equal to plus 3 volt. And feedback resistor RF is equal to 6 kilo ohm, and all the three resistors are equal. So R1 plus R1 equal to R2 equal to R3 is equal to 4 kilo ohm. So now we know that for the inverting summing amplifier, output voltage V0 is equal to minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. See now here in this the given problem, all the three resistors are equal. See when R1 equal to R2 equal to R3 is equal to R, we can write this expression as V naught is equal to minus RF by R into V1 plus V2 plus V3. So now substitute the values in this equation. RF is equal to 6 kilo ohm and R is equal to 4 kilo ohm into V1 minus 4 volt and V2 minus 2 volt, then V3 plus 3 volt. So it is minus 3 by 2 into minus 3 is equal to minus 4.5 volt. So the output voltage in this PAMP adder circuit is minus 4.5 volt. Okay, thank you.